Right. In the previous class, we learned that there is a standard needed for a device to be a part of internet. The device need to be built as per the standard so that all the device will communicate with the same fashion to understand one another. And that standard is open system interconnect. When a device send a traffic to a remote device or a local area network device, the data is prepared using an application. The application which can interact with the internet. For example, the one which we are attending the class, Google Meet. It's an application that can interact and over the internet. See, the Paint which I have opened for writing this is not a network application. But we join the call so that you can hear my voice, I can hear your voice, and I can share my screen and vice versa. That is a network application. That is what we call here as application layer. Now this application layer, which is layer 7, generates traffic. There are various traffic types. Not every application generates same type. See, when you ping, it is ICMP traffic. When you telnet, it is different, not ICMP. It is TCP. When you do multicasting, it is UDP. See, depending on the application that you use to interact with the network, the protocol is determined. Not every application uses the same protocol. Then we don't need different applications, right? We have an application called Outlook, screen share. We have an application tool like WinSFP for doing STP, for doing SSH, Telnet. We have PuTTY. We got various type of application. Each application does different job. When you go to a bank, you cannot ask the manager of the bank to open door for you. Though he is a part of bank, his job is different. There is a security. If you want, you can ask him to open the door, but not the manager. I cannot ask security to sign in the place of manager to get some approvals. For that, I need to approach manager. So everyone in the bank are not the same. Though they're all bank staff, though they all get salary from same organization, they are not all same. Similarly, though the traffics are coming out of the same port, but the traffic that comes out of the port are different. That differentiation is based on the application that you choose, that you have chosen to communicate. That's what the role of application layer. It provides the application for the type of communication that you want to do. And when you open the application, immediately a presenter comes. A presentation layer, a presenter comes. And now the presenter will say to the network what sort of application has generated this traffic and how the traffic need to be handled by the network. I repeat. Presentation layer, see the word presentation. Presentation makes the network understand how the traffic need to be handled. Makes the network to understand this is not a ICMP ping traffic, this is a telnet traffic. Or this is HTTP traffic. Or TLS traffic. It's the job of the presentation layer to make the network understand about the traffic which the application has generated. See, you and I understand very well because we installed the application. We double clicked the link that I gave you, Google Meet link. And we know that the application is going to be Google Meet. But how the network will know that these traffics are coming from Google Meet? No problem. Presentation layer makes the network understand what type of traffic this is. See, when you double click the link that I shared with you for joining the class, you know it's a Google Meet. And you join the class. How network understands that this is the Google Meet traffic? From my laptop, there may be many other services also running parallelly. They also generate traffic. So now all goes through one single port out of my laptop. It may be a physical NIC card or it may be a radio waves for wireless. Doesn't matter. It's going to be via one particular port. So there is a need for a presenter to tell the network what type of traffic is this to the network, so the network will handle it accordingly. When you check in an airport, you will tell that I have a breakable item inside my check-in baggage. On hearing what you said, immediately what this boarding the member does is, the staff does is, they put one sticker with a nice champagne glass picture. They put a sticker on your box. They are presenting to the ground staff a message saying, this is not a normal baggage. This is a baggage that you need to handle with care. Why? Because there is some breakable inside. So they present it so that application layer no need to go down to the physical layer and say, this is a breakable item. That boarding pass staff need not to go to the ground staff wherever the bag goes saying this is very important bag, please handle it with care. No need to do that. All that she need to do is that boarding staff, mostly they are women's working, so I'm saying she. What she need to do is just take a sticker, stick it on the box, bum bum, that's it. The belt takes the baggage inside the airport. The people who are handling my baggage, they know that this is a vulnerable item inside. This baggage need to be handled with extra care. Likewise, we have various type of application. Some application generates time sensitive traffic. Some application generates not so important. So a presenter need to tell the network that this is a very fragile traffic, sensitive, time sensitive, tiny traffic, which can be lost. So give high priority. Something like that, you see. The presentation layer need to present it and make the network understand exactly what the traffic is about. You and I understand, when I open a browser, I understand it is HTTP or HTTPS. But how network knows that it is HTTP or HTTPS? That is the job of presentation layer. Whenever you read the book, they will put something which you don't understand, no way related to this, what I have said. Encapsulate, encrypt, all nonsense. No. This is the actual meaning. When they say it encapsulates, what does that mean? It attaches the information about the type of traffic that the application is sent, so that network will handle it according to the information that has been presented. Now comes the next layer. The data is now comes down to layer 5, where a session, a time frame, a time stamp is attached. Yeah. So the session layer attaches a timestamp saying this application's traffic need to be sent within this milli-microsecond, and if there is any response needed for this from the destination, it should come within this second, within this number of seconds. That is what session layer. See, when you ping, I want to show you that. When you ping www.yahoo.com, you can see here 12 millisecond, 11 millisecond. Oh, what is this? That's the time taken for you to get the reply back. A request to send from my laptop, Bengaluru, to a Yahoo server, wherever it is, let's see where it is. To reach that Yahoo server and get the response back, it has taken 12 milliseconds. So that's my gateway 192.168.1.1. From there it goes to my ISP 100.65. See, it is going to VSNL Bangalore 1414, and then it goes to 172.31. That's another public address. And then it goes to Chennai. From Bangalore it has gone to Chennai all the way. And now, okay, in Chennai only they have one server, I think. So you can see here the time taken is 11 milliseconds. So it won't wait for a long time, you see, if it isn't, say for example, I'm going to put some spelling mistake, Yahoo. Okay, no, don't put number. There is no one like that. So it won't wait for a long time. It should not wait for a long time. I think there is someone having this spelling also. Okay, you already got star. Means it is timing out. It says time out. There is no one responding. There is no one responding. See, request timed out. There is no one called yahoo.com. All right. So that's the reason why you need session layer. It maintains the time. If the response is not coming on time, it will immediately say that request timed out. So for every application generated traffic, there is a time frame. Within this time it has to leave. Within this time it has to get the response back. If the response doesn't come, then what to do next? All those things are there. So session layer is taking care of this timing. I'll give you another example. When you download, it shows the time. It shows how many seconds or minutes it will take to complete the download. How your PC can show you that? Session layer. If the size of the file is 200 meg, if the download speed is 100 meg, how long it should take? It calculates and says approximately it's going to take 2 seconds or 3 seconds. That's the job of session layer. See, everything in networking, in computer world, the IP world is time based. Everything is time based. That's why time is so important for computers. Right now the CPU is running in a particular speed, and that speed is measured with time, megahertz. What is it? Hertz, time. Millisecond, time. Ethernet cables, we say 10 megabits per second. That's the speed of an Ethernet wire. Fast Ethernet wire, we say 100 megabits per second. See? Per second, that's how we measure. Per second, this can send 100 meg. Per second, this can transport 10 meg. Gig Ethernet, 1000 megabits. Everything is measured with respect to time. That's why we need what? Session layer. And now your data is presented and the time frame is given. All these three things are taken care by your operating system. You have nothing to put a hand there. You don't have anything to do with those 3 layers. Now comes the transport layer. Even the transport layer is taken care by the operating system. But when you work on a firewall, you can do some changes to port numbers, which works on this transport layer. Transport layer is layer 4. Transport layer is responsible for transportation. That's why the name is given as transport layer. There is no name just given like that. For every name there is a meaning. They didn't simply randomly give some name: application, presentation, session, transport. Because there is something related to transport, this layer is called as transport layer. Without that thought, learning about transport layer is going to make impossible to understand it. Yep, transport layer. So definitely there is something related to transportation. That's why it is named as transport layer. Transportation. Yes. You see, I just now gave you the speed, capacity of wire. If it is Ethernet, if it is an Ethernet cable, only 10 meg of data per second it can send. If it is fast Ethernet, 100 meg it can send and receive. And if it is gig Ethernet, 1000 meg it can send and receive. So now, how do we know what cable is connected to this PC? Because according to that capacity of the wire that you have connected, the transportation department need to say the size of your packet. I repeat, when I have booked a small car, a small mini car, my family member will know that not everyone is going from our house. It's going to be daddy and mummy, no one else. My children understands that. Okay, it's a small mini car has come. Not everyone is going. Only 2% is going to go. When a big 12-seater comes, then they understand the whole family is going to go. Yeah, that is what transport layer does. According to the capacity of the cable that you have, the transport layer collects that information from the physical layer and determines the size of the packet. The data that you may be sending is too big for transportation. This wire may not carry as a single piece. Okay, so you have, let's say, you have 30 tons of gold. 30 tons of gold. You want to transport. If I bring one small jeep, can I send all 30 tons of gold in one jeep? No way. I have to see now. A jeep can take maybe 250 kilo. Then I need to calculate how many jeep or how many pieces, how many group, how many, this 30, how many small, I need to divide. I need to, this 30 tons, I need to break into many pieces. And every jeep will take one piece. Only then it is possible to transport. You can't send 30 tons of gold in one jeep. That is determined here. How many small pieces I need to make. Let's say I need 3,000 pieces. And this is the first piece. This is the second piece. I need to sequence it so that I can rejoin on the receiving side. Hey, this is not just gold, this is data. You cannot join the third piece with fifth piece. third piece should be joined in the front with the second piece, at the back with the fourth piece. So the sequencing is very important. The numbering should be done. So what I'm trying to say is, your large size data that you generated in the application layer, when it comes to the transport layer, according to the capacity of the media that you have, transport layer segments the data and sequence it, puts the number. This is the first piece, this is the second piece, third piece, so that if the receiver receives in a shuffled way, still they can manage to rearrange it in an order when they join the data as one data. Only for transporting this has been segmented. The receiver is not going to read in segments. When the receiver's application shows you, it shows by combining all pieces together. That's what the receiver's transport layer will do and send it to the session, presentation and application layer of the receiving device. So transportation is taken care by this transport layer. That's what we need to know. This is what the meaning of it. This is the meaning of responsible of transportation. Takes the responsibility of transportation. So, you see, there is some portion of this OSI takes responsibility for transportation, but it is not a first step, it comes as a fourth step. The sequence is very important. Session layer has to finish its job. Only after that, segmentation happens, sequencing happens. Not only that, based on the application that you picked here to communicate, the port number is determined here. Port number. Port number comes into picture in the transport layer. Not only that, whether to use TCP or to use UDP is also determined here. See, when we talk about transport layer in the next round, I'll talk about these port numbers, TCP, UDP. As of now, I don't want to dump too much about transport layer today. What we need to know in today's class is transport layer does segmenting of data according to the capacity of the medium. It segments it and it sequences it. It puts the sequence number. It sequences, and not only that, it assigns port number according to the application that we used. For example, when we are using HTTP page, port number 80 is assigned. If you are going to Telnet from the application using the Telnet application PuTTY, then it is going to be 23. Transport layer determines the port number based on what the presentation layer told about the data that is generated by the application layer. Presentation layer said this is Telnet traffic. Okay, then I'll give 23. And transport layer also decides whether to use TCP or UDP. TCP is connection oriented, UDP is connectionless. We'll talk about this in detail in our next class. Now, next layer is the network layer, layer 5. Network layer. Network layer job is to involve the protocol IP. Yes, correct, layer 3. Oh, I put 5 there, sorry. Layer 3. Now, network layer, layer 3, involves this network layer protocol. Whether to use IP or IPv6 is determined here. See, the information about the application is what so far we have seen in this first top four layer. Layer 7, layer 6, 5 and 4. When I say first 4, it doesn't mean L1, L2, L3, L4. Here it means layer 4 to 7. We have never spoken anything about to whom to deliver, how do you identify that the receiver. All the stuff is not been spoken in this application presentation and session and transport. It is this network layer which is going to say this packet belong to, this data belong to so and so in that network. It may be identified using IPv4, maybe with IPv6, it depends. Today we have IPv6 also in place. Right? So, network layer assigns the source and destination IP. Source and destination IP address. More about this is coming in coming classes a lot. It may be IPv6 address or IPv4 address. It depends on what you have enabled in your laptop or in your network. The protocol IP also works in this layer. This is where it has to work now, because this is where we have address. Wherever the address is, the protocol IP will come. This address, let's say 10.0.0.1, this is called as IP address because the protocol IP is going to deal with this, use this, understand this. No other protocol uses this. It's the IP protocol. We are in the IP network. The entire world is speaking one common language called IP or IPv6. So that is why we are able to talk. It's like we all have one common language, English. There are some countries where there is no English encouraged. But even they also now somehow start learning English. Like our friendly country, North Korea. And that's how media says. I am not sure about that. Who knows? I know there are people from North Korea in the US studying. Government only sent them. So there is a common language to identify called IP. Now we have IPv6, another version of IP. Network layer is the one which is attaching the ID, from ID to ID. It's like a from address and to address to the envelope that we write. Okay, now once it has got the IP address, our data now called as packets. It was segment. When it got the port number, now it is packet. Same data, once it receives the IP address on it, the name is given as packet. When someone is talking about segment, it means that they are talking about our data in the transport layer. Still it has not received the IP address. If someone says packet, mostly it means data. But with respect to OSI, it means it's layer 3 data. Data in layer 3. With respect to OSI, it is layer 3. Data is in layer 3 when someone says packet. But in general, if someone says packet in networking, it means data. So we should not get confused with the term later. When I say packet is coming, I don't think, I'm talking about layer 3. In routing class, in later classes after OSI, when I say packet, it means data is coming. But here in OSI, when I say packet, it means it has got the IP address, port number, session ID, presentation markings, and the application markings. Nothing related to data link layer is still not added yet. Okay, now comes layer 2, data link layer. We call it as data link layer. This is the one which is going to put the data over the link, whether it is Ethernet or fast Ethernet or gig Ethernet or fiber channel or IEEE 802.11g wireless. The data is going to be kept for transport. This data link layer is what adding this protocol, Ethernet or fiber channel or fast Ethernet or gig Ethernet or Wi-Fi protocol or PPP protocol, which is a WAN protocol if you have serial, or a HDLC. So any one of this protocol need to be encapsulated to your packet so that the wire can transport it. See, we call it as Ethernet wire. You might have seen that Ethernet wire. It is just a twisted pair cable. In physics you might have learned. Shielded twisted pair cable. Then why are we calling it as Ethernet wire? That protocol Ethernet can operate, can work over it, can work on it. That's why it is called as Ethernet wire, Ethernet cable. The protocol name is Ethernet. Protocol name is FC. Protocol name is GE. Protocol name is fast Ethernet. Protocol name is PPP. Protocol name is HDLC. That is determined here, which protocol to use. Depending on the cable, if you have a fiber channel cable, fiber, then it is going to use FC in the data link. Not the Ethernet. So in order to place the data over the link, a suitable protocol need to be encapsulated. That is determined by this L2 layer. That is why this L2 layer is called as data link layer. So once that protocol is determined, it gets a new name called frame. It's called frame. And now, what happens next? It is placed inside the medium with that protocol. Now the media converts the data into bits and bytes. If it is Ethernet or FC or fast Ethernet, if it is Wi-Fi, then it is going to convert it into radio waves. Who? The physical layer. So physical layer only decides whether to send this zeros and ones of data in a radio wave antenna or via the NIC card, the duplex, full duplex, half duplex, all these are determined here. That's why it is called a physical layer, connectivity, physical connectivity. how am I going to communicate? How I'm going to connect to transfer these bits and bytes. See, the 7 layers, meaningful. You can't miss any one of this. All these things are needed. So here, data link layer adds the source and destination MAC address. Like we have IP address added in the network layer, in the data link layer, MAC address is added. We'll deal with these things in detail in our next class. I'm just giving you overall now. Whatever we have seen up to session layer is the same, there is nothing to add, but we are going to add something more to the transport layer, network layer, data link layer in coming class. Do you have any question? Okay. Right. If no question, we'll stop here today. We'll continue this. We are going to do one more round of OSI to understand much more in depth, and then we will move on.